then disjoint set. Next one is difference of two sets. And last one is complement of a set. So these are the main 5 operations inside set operations: union of two sets, two or more sets, intersection of sets, disjoint set, difference of two sets, complement of a set. Okay, in our last classes we have discussed what is the definition of set, how can you represent a set, and what are the types of sets. Today we will cover these 5 operations with the help of Venn diagram. So take the first one, union of sets. Suppose you have two sets, 1, 2, 3, 4 are the elements, and there is another set whose elements are 4, 5 and 6. Then the union, the another name of union is join of sets. So we will write in that way, A union B is a set. This is a set whose elements will be from A or from B. Okay, so from A what are the elements? 1, 2, 3, 4, and from B what are the elements? 4, 5, 6. So you can't write 4 again because you have already written it. So 4, 5 and 6. This is the union of A and B. So this is union of A and B, whose elements are the elements of A as well as the elements of B. Now if I discuss this union using Venn diagram, what it will look like, you know that in Venn diagram we will use a rectangle which indicates the universal set, and inside the universal set you have to draw the circles that represents the sets. So here the A and B. So I am drawing, this is set A and this is set B. This is A and this is B. Why there is a common part? Because A and B both has a common element 4. So in the common part you have to write 4. Okay. Then what are the other elements of A? 1, 2, 3. So write 1, 2 and 3. And what are the other elements of B? That is 5 and 6. So it is 5 and 6. So you can see inside A the elements are 1, 2, 3, 4, and inside B the elements are 4, 5, 6. Okay. Now what is the A union B? If you want to find A union B, then you have to shade, I am using the straight lines here, you have to shade it using straight lines. First you have to set the set A, because A union B are the elements of set A or set B. So I am first I am shading the set A, that means I am taking all the elements of A and again all the elements of B. So again I am shading the set B. Okay. Now the shaded region will indicate what is the A union B. Now you can see that inside the shaded region the elements are 1, 2, 3, 4, 5 and 6. So A union B is 1, 2, 3, 4, 5 and 6. So this is the A union B. So this is our first important operations, union of two sets. Okay, I am taking 2. If there are 3 sets, then you have to take all the elements of 3 sets. Next one is intersection of two sets. This is the number 2. Again I am taking the set A and B, the previous set A and B, and what is the intersection of two sets. Okay, in that case we will write in that way: A intersection B. This is a set whose elements, if I write the property in property method, you can write it in that way: X such that X belongs to A and X belongs to B. Okay, that is X belongs to A, and this is the AND symbol. This is the AND symbol. X belongs to B. Okay, now see the definition. What is the A intersection B set? It is a set whose elements are from A and B. That means here we are using AND. In case of union, we have used X belongs to A or X belongs to B. Okay, these are the difference in between union and intersection. Whenever you are taking the intersection, you have to take the common elements in between A and B. Okay, that means that element which is belongs to A and which is belongs to B. That means the common elements. And in case of union, I am taking the elements which are belongs to A or X belongs to B. That means the elements of A or X elements of B. So this is the main difference in between union and intersection. Okay, then what are the elements of these two intersection of these two sets? A intersection B is the common elements, that means 4. Okay, A and B have the common element 4. There is no common element, so A intersection B is only 4. Now how you can represent this intersection in Venn diagram? Suppose this is the universal set U. Again I am taking the set A, and since it has a common part, this is B. Inside common part it is 4, and other elements are 1, 2, 3. Here other elements are 5 and 6. Okay. So the common part is this one. So I am shading this part. This is the intersection of these two sets, and you can write this as A intersection B. The shaded region is this region is A intersection B. Okay. So whenever you are taking the intersection, you have to take the common part of the sets. Okay, so union and intersection. The next one, and okay. Now if the sets it doesn't have any common part, then we will say that the sets are disjoint. These sets are joint set. If it doesn't have a common part, then the sets are known as disjoint. That means if the intersection part is null set. Okay, let's take an example. What is disjoint set? Number 3 is disjoint set. Okay, first I am drawing the Venn diagram. This is universal set, this is set A, and this is set B. See, there is no common part. That means set A and set B both are disjoint set. Okay, so what will be the definition of the disjoint set? A and B will be disjoint if A intersection B is a phi set. That means there is no element in the common part of A and B. Okay, this is a phi set, or you can write null set. The representation of null set is phi. Okay, so whenever the intersection is a phi or null set, then the sets are disjoint. Next one is, the next operation is difference. Difference of two sets. And this we will indicate in that way, A minus B, or A, that is a symbol. You can use any one, this one or this one. This will indicate that the difference between A and B. Okay, first I am writing the definition of the difference. A minus B will be that element, X will be from A, and okay, here I am using the symbol, this is AND symbol. X belongs to A and X doesn't belongs to B. Okay, so I'm taking an example first. Suppose A is a set whose elements are 1, 2, 3, 4 and 5. Another set B whose elements are, suppose, 4, 5, 6, 7. You can see 4, 5 are the common elements. That means these two sets are joint set. And what will be the A minus B? A minus B is a set whose elements are from A and not from B. Okay, whose elements are from A and not from B. See the elements of A 1, 2, 3, 4, 5. Okay, but 4, 5 is present inside the B. The 4, 5 exists inside B, so you can't take 4, 5. This 4, 5, because the definition is saying that X is from A but and not from B. So only you have to take 1, 2, 3. This is the A minus B. That means eliminate the elements from A which are inside B. 4, 5 are inside B, so I am eliminating 4 and 5 and taking other elements of A. So that indicates A minus B. That is the difference of in between two. Now what will be the Venn diagram of suppose this is the universal set U. This is set A. This is set B. Okay, inside A, what are the common elements? 4 and 5. And inside A there are 1, 2, 3. And here B will be that set whose elements are from A but and not from B. So you have to take the elements from A and which are not from B. So this is the set A minus B. See, you have to eliminate the common part. So I am taking the elements which are from A and not from B. So this is the Venn diagram of A minus B. And our next operation is complement of a set. Fifth operation is complement of a set. Okay, and we will denote this complement. Suppose A is a set and its complement will be A bar, or sometimes it is A complement, that is in the power it is a C, small c. Okay, suppose A is a set whose elements are 1, 2, 3, 4. And in that case, we need the universal set. And suppose the universal set of A is 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the universal set of A whose elements are 1 to 8, and the elements of A are 1, 2, 3, 4. Then the complement of A is simply it is U minus A. That means eliminate the elements from universal set of the elements of A. So you have to eliminate the elements of A from universal set. Okay, this indicates the difference in between universal and set A. So you have to eliminate the elements of A from universal set. So what are the elements of A? 1, 2, 3, 4. You have to eliminate this element from universal set. So that means U minus A is only 5, 6, 7 and 8. So this is the complement of A. If A is 1, 2, 3, 4 and the universal is 1, 2, 3, 4, 5, 6, 7, 8, then what is the complement of A? Don't take the elements of A and rather take the elements of U, but after eliminating the elements of A. Okay, so A complement is U minus A. Now see the Venn diagram of A complement. Suppose this is the universal set and this is the set A. Inside A, the elements are 1, 2, 3 and 4. And inside universal set, the elements are 1 to 8. Already 4 are inside A, that means 5, 6, 7, 8 will be outside of A. Now what will be the A complement? A complement is take the elements of U which are not from A. So this is the elements of U except the elements of A. Okay, that means you have to take all the region except the region of A. So this is the Venn diagram of A complement. So we have discussed 5 set operations. Union, first one union of 2 sets or many sets, then intersection, and then what is disjoint set, then what is the difference of 2 sets, and then what is the complement of a set. So using this Venn diagram, further we will discuss more things. For now, let's take one example. Okay, suppose this is a question. Suppose A is a set whose elements are 1, 2, 3, 4, and B is another set whose elements are 2, 3, 4, 5. Okay, and there is another set C whose elements are 1, 3, 4, 5, 6, 7. There are 3 sets. Now find A minus B, then find A minus C. Then show that A minus of B intersection C is equals to A union B minus A union C. So this is a question. A, B, C, 3 sets are given First find A minus B, then find A minus C. After finding these two, show that, sorry, this is A minus B union A minus C. Okay, then show that A minus of B intersection C is equals to union of A minus B and A minus C. So we'll do it step by step. First one is first find A minus B. So AB is given from the definition number 1, A minus B. What are the elements? A minus B, that means eliminate the elements of B from A. Eliminate the elements of B from A. So what are the elements of B? 2, 3, 4. So eliminates 2, 3, 4 from A, and the remaining element is only 1. So A minus B is the set having the element only 1. Okay, so this is number 1. Okay, again I am repeating it. So A minus B, that means eliminate the elements of B which are common in between A and B. That means 2, 3, 4, 2, 3, 4. Okay, so eliminate the elements, the common elements in between A and B, and write the elements of remaining element of A. So so A minus B is only a set having the element 1. Okay, this is number 1 we have done. Now find A minus C. That means eliminate the common elements of A and C from A. So what are the common elements? 3 and 3, 4. 3, 4 and 3, 4 are the common elements. So eliminate this element from A. That will give you A minus C. That means the remaining elements are 1 and 2. So this is A minus B, this is A minus C. I think you understood what is A minus B. How can you find A minus C? Okay, then what is in the question? Then show that A minus B intersection C. So you have to find now B intersection C first to find out this. So we are going to find out this part. Okay, so what is A minus B intersection C? So we can write the A first. You have to do the first bracket thing first. So I am writing A. A is the set 1, 2, 3, 4 minus B intersection C. Now B, C. These are the sets. What is the intersection of these two sets? And you know that the intersection means the common elements in between B and C. So B intersection C is, what are the common elements? 2 is here, 2 is not here. 3, 3. Okay, this is 3. So 3 are the common element. Then 4, then 5. So 3, 4, 5 are the common elements in between B and C. So B intersection C will be 3, 4 and 5. So it is 3, 4 and 5. Okay, A 1, 2, 3, 4 and B intersection C is 3, 4, 5. Now what is the difference in between these two sets? You have to eliminate the 3, 4, 5 from the set A. So there is 3, 4. So you have to eliminate this 3, 4. 5 is not there, so don't take 5. So ultimately we have, if you eliminate 3 and 4, then we have 1 and 2 only. So A minus B intersection C is the set of elements 1 and 2. Okay. Now we have to find, this is the, you can say this is the left hand side. Okay, left hand side is equals to 1, 2 set. Okay, I am erasing the first part. Now right hand side. What is in right hand side? Union of A minus B and A minus C. See, we have A minus B and A minus C. What is the union? Take all the elements of these two sets. So 1, 1, 2. There are two ones, so you have to take only single one, because there you don't have to repeat numbers inside a set. So the elements of union of these two sets are 1 and 2 only. See, the left hand side is a set having the elements 1, 2, and also the right hand side is a set having the elements 1, 2. That means these two are equal. Therefore, you can write A minus of B intersection C is equals to A minus B union A minus C. So this is the solution of the question. So using the operation you can solve that type of problems. So these are the basic operations on set theory. Except these operations, there are certain laws in set theory. Okay, the first one is associative law. Okay, what is associative law? In arithmetic or in algebra, you know that 1 plus 2 plus 3 is equals to 1 plus 2 plus 3. This is known as associative law in arithmetic. Okay. Similarly, in if you do A union B union C, that will be equal to A union B union C. Okay, this is the associative law in set theory. Also, all of you know that the commutative law. What is that? A union B is equals to B union C. Okay, I am writing the laws only for the unions. This is also true for the intersection. That means A intersection B is also equals to B intersection C. So this is the commutative law. You can prove that laws using Venn diagram. Okay, so these are the two laws, associative law, then commutative law. Then there is another important law, that is distribution law. Distribution law. And what is distribution law? A union B intersection C is equals to, distribute it, A union B intersection A union C. That means A union B, then intersection, then A union C. Just like 2 multiplied, or in case of algebra you can write x A plus B. This is nothing is here, that means the multiplication is here. A multiplied A plus B, that is x multiplied A plus x multiplied B. Okay, this is known as distribution law. Okay, similarly x union B, then intersection A union C, just like x into A plus x into B. This is distributive law in set theory. Number 4, this is important law. It is known as demorgan law. Okay, demorgan law. And what is that? A union B complement is equals to A complement intersection B complement. This is very interesting. A union B complement, which is equals to A complement intersection B complement. Okay, all these laws you can prove by Venn diagram. let's see how you can prove this law by Venn diagram. So the demorgan law. This is a law: A union B complement is equals to A complement intersection B complement. Now how you can prove? We will use the Venn diagram. Okay, let's take the first we will find the region of the left hand side. Okay, for that I am drawing two Venn diagram. For left hand side I am drawing two Venn diagram. Okay, this is universal set, this is set A. Okay, let's take a bigger one. This is set A, this is set B, set A and set B. Now first, what is inside the bracket? A union B. So take the A union B. We know that what is the A union B? We have to take all the region of A and B. So this is A union B. Okay, first I am drawing the A union B. But what is in left hand side? A union B complement. Okay, next I am taking the complement of that. Okay, suppose this is the U, this is A, this is B. Now if A union B is the region of that portion, then what is the complement? Subtract the A union B from universal set. So this is the universal set. If you remove this part from universal set, what will be the region? This is the region which is A union B complement. So finally, what is in left hand side? That region is in left hand side. Okay, now take the right hand side. Right hand side is A complement intersection B complement. This is universal set, this is set A, this is set B. Okay, now first I am taking the A complement. If A is the set, what will be the complement of A? Except the set whole universal set. Okay, I am using the horizontal line for A complement. So this is, I am not taking the A set. Eliminate the A set only from universal set. So I am taking horizontal line for A complement. Okay, I am writing here A complement, these lines. Okay, now next one is B complement, and in case of I am taking vertical lines for B complement. Okay, so B is that set. You have to draw lines except B set, that is a B complement. So if I draw the vertical lines, so don't draw the lines inside B. B complements, that means the lines outside of B, only B. So these are the lines which indicates the B complement. So this is A complement and B complement only. Okay, now you have to take the intersection of A complement and B complement. So what will be that set? Suppose this is the universal set. Okay, in case of intersection in Venn diagram, take only the double line is there. Okay, take the region where the double line is there. Okay, see there are the double lines just only outside of A and B. Inside A, single line. Inside B, that is also single line. So whenever you are taking intersection, take the double lines. Okay, so double lines region is only outside of A and B. So if this is A, this is B, then A complement intersection B complement, the intersection is only the double lines. That means the outside region of A and B. See where the double lines are. This part is having the double line. So see the right hand, these two images, these two diagram. The shaded region in this part is equal to the shaded region in the second part. That means A union B complement is equals to A complement intersection B complement. So using the Venn diagram, you can prove the laws. Okay, so this is the proof of demorgan law. So in that way also you can prove. Suppose this is a question. So question is using Venn diagram, prove that A minus B intersection C is equals to A minus B, which is union of A minus C. Okay, this is a question. We already proved that one. The previous example we have taken, we proved that relation. But in that case, use the Venn diagram and prove that one. This is an exercise for you. You will try it at your home. So using Venn diagram, you can prove any laws, and using Venn diagram, there are many problems you will face when you try to solve the problems in your exercise in your book. So this is the operation of sets, and this is how you can use the Venn diagram. So that's all about this class. If you missed the last classes, you can watch it from our Facebook page, and also we have a YouTube channel which is rPiXY Study Buddy. You can find many lectures in our channel. So go to our channel and watch our lectures. There are various teachers are there, and various topics they have discussed. And if you like our classes, please share this video to your friends. That's all. Thank you.